Hello, everybody. My name is Attila Bogár.
Hi, I'm Tamás Jós.
We are two guys working on the IT security field with
Yes.
different backgrounds.
Exactly.
And we had a good idea, I believe so, it was a good idea, to check out what the people are thinking. Is it real or not that if somebody is using BitTorrent networks, is it anonym or not, or who knows what is happening in the background?
Yeah, well, basically we will see that everybody knows everything about current torrent networks and peer-to-peer networks, and just to show you the depths of what can somebody acquire, what can somebody find out if he basically just monitors and logs around and sniffs around the BitTorrent networks or peer-to-peer networks.
So what we did, we have put together a piece of software, a kind of proof of concept level.
Yes.
And basically logged what is happening on the peer-to-peer networks, especially on the BitTorrent networks.
Yes, but we will see that in details in the presentation.
So let's move. First of all, let's see the P2P networks itself. If we are talking about peer-to-peer networks, or if we are talking about BitTorrent, everybody's thinking about the file sharing. File sharing is not started with BitTorrent, of course. There was the very famous Napster, then the later ones, but also, originally, the internet, in the age of the ARPANET, it was a different how they think about it. And not surprisingly, it was a peer-to-peer network, as they originally think about how to create the internet itself. Also, we are using peer-to-peer networks if we are using instant messaging applications like Skype originally, before the Microsoft time. It was purely a peer-to-peer application. Also, the streaming media using peer-to-peer technology. And we shouldn't forget about the military area, how the whole internet been started. So they are still using the peer-to-peer networks. Why they are using it? Because of the flexibility and what they think, the security. So let's move on.
Not to mention the robustness. And one more example, Facebook is using BitTorrent protocol to distribute updates on its servers, on its internal servers.
Okay.
Okay, so first thing, just to give you the basics of how this whole torrenting stuff works. Basically, the first thing you do usually is to acquire a torrent file. If you are opening this file, you will find that it's mostly full of text, full of strings. Actually, it's a bank-coded data structure, which is basically the torrent file itself is a huge dictionary. This dictionary contains lots of information about the actual torrent. For example, where can somebody have peers for this torrent? This is usually in the original BitTorrent version. This was called the tracker because originally BitTorrent was focusing on relying on one server or multiple servers to acquire peer information from. The second thing, of course, is the file actual name. There can be as well commands or creation dates. And another really important piece of information inside of the file is the pieces, the so-called pieces. This is how it works, basically, if you are grabbing a file, not a BitTorrent file, just a data file, and you want to distribute it on BitTorrent networks, your software, which creates the torrent file, basically grabs pieces out of the file, let's say chunks or pieces, and applies an SHA-1 function to each of these pieces and stores them inside of the file in order to later on, when you are downloading the actual data from other peers, you can validate that this piece is actually a piece from the file and somebody else not trying to fool you by providing you false information about the file.
So with that way, we can make sure that the original file we have got in a torrent, through a torrent file, it is truly the original file you are get. And also, when you are downloading the different pieces, you can check with the SH1 hash that that particular piece is fully downloaded and it is good. So it is checking itself.
Exactly. But the most important information of this torrent file is not not a string or a data structure, but an SH1 hash of part of this file, which is called an info hash. This info hash is used by the client and by the tracker as well for identifying, uniquely identifying the torrent you wish to have peers from, you wish to download.
Yeah, so basically when we are talking about we are downloading a torrent file, actually in behind the walls, we are downloading piece of information connected to one identifier which is called the info hash. This is important because later on we will show how can we reveal the fact nowadays people are using the internet, that everybody is having multiple places they are connected to the internet. On the working place, during, on the move and at home. So with this particular information, it is possible to connect the dots and see if somebody is downloading one piece of, let's say, content, and this downloading is moving from one place to another. So it is possible to track that particular user, either where it is moving and what are the different IPs and how is it connected with each other.
Okay, I already
moved please.
It. So let's say the newer version where you can use to acquire files from BitTorrent network is called a magnet link. It's not a file anymore. It's basically a URL which triggers your browser to execute to give this data to one of your favorite BitTorrent client, and this magnet link is not the same as a basic torrent file. If you can see up there, this was one example we just acquired from the internet. So you can, in this magnet link, you can find the actual info hash. Previously, in the torrent file, your client had to calculate the info hash. Here, it's out there, plain text. Of course, you can see the file name and the trackers. And basically, that's it. This whole magnet link idea was brought to life by, according to the internet, by Pirate Bay. But and it later on got into the BitTorrent specification. And it's kind of a cool thing because usually you don't, if you want to store large pieces, large amount of torrent files, eventually, if you are really talking about huge amounts of torrent files, it will burden your hard disk. But if you are only storing the necessary information about the torrent file, which is the info hash and the info hash file name and the trackers, then you can save lots of spaces. So what my colleague found on the internet, that eventually only storing this information, you can run an actual BitTorrent tracker with 90 megabytes of hard disk.
Yeah. The real question is why it is interesting, why this whole magnet link stuff has been started. I believe so. Lots of people are using torrents in this room. The original thing is that, of course, there are a legal question behind this whole story. Every countries have a different legislation about downloading. Hungary is a wonderful country, of course, because in Hungary you can download it for free. However, the torrent situation is quite different. And in the last summer also, we have seen a different new version of legal requirements. And there are still, let's say, a discussion between lawyers what actually the new way means. But the point is, there are different countries where even a simple download of media files is also something which is against the law. So the original story started with Pirate Bay. If we are moving back to them, their story ended with the way that the actual government in that particular country was able to sue them, and finally they got some problem with it. So there was a thinking about to let live the whole torrent idea, but not using the same way the torrent servers as it used to be. So that's why the magnet link's there, because the magnet links are really not containing anything about the actual content anymore, just the pure base information to start and collect the first step information. So it is now a 0 step. So we will talk about 2 different kind of networks.
Yes.
One is the torrent-based network.
Tracker.
This is the the tracker-based network. In this case, the trackers, the main ones, which are keeping these torrent files. The trackers can be free ones. The trackers can be private ones. And if you are able to download the file, after that, you can start the torrent communication.
Exactly. So basically what tracker-based peer acquiring looks like, I will show it on the next slide. We put together a small animation for it. Right now, the tracker-based network is, although there can be multiple trackers inside of a BitTorrent file, if we are just looking at one simple tracker, we can say that, however, the whole network is peer-to-peer. The downloads are coming from multiple sources towards your computer. But the first step, how to get peers, how to get IP addresses of other information who are willing to share the same data with you, is focused on these tracker servers. So the tracker, no, please don't. The tracker server communication can be over HTTP or can be over UDP, which is a bit ambiguous because they are mismatching in layers. So the original idea of getting peers from a tracker came from the client was sending an HTTP GET request, which contained all of the information showing the info hash, the uploaded part, downloaded part, and so on to the tracker server. And in an HTTP response, the actual tracker gave back a bank-coded list of IPs, which were the peers who were actually downloading that particular torrent or sharing that particular torrent. But eventually, the whole communication became so let's say,
overloaded.
So huge for these tracker servers that using a TCP connection, even the TCP headers were taking up the bandwidth of these trackers. So eventually they moved to UDP, and nowadays most of the modern tracker servers are on UDP. Over UDP, the same communication, almost the same communication exists. So the same data flows, same let's say request data flows almost over HTTP. It's just about the smaller packet rate.
Yeah. So this is the way how we can see the original tracker-based one communication is building. So this is the first. We are moving to the tracker. We got back the address, and after that, start to talk with all the other peers. So here, the main problem, let's say from security point of view, if there's no tracker, there's no communication. Let's talk about the free-ish private trackers.
So inside of the private, what is the difference between free tracker and the private tracker? Obviously, the private tracker wants to know information about you, what you have uploaded, what you have downloaded. So, and this is because they want to avoid leechers. Because leeching is a really, really bad stuff. You just download the file. You don't want to share this file anymore, and eventually it will make people go away from your tracker. So if you're a tracker administrator, obviously you don't want people like this to be involved with your tracker, like you. Yes. So how do they do it? Here we can see a free tracker URL. This is basically the URL that gives out information about peers who are downloading it. And my colleague was sharing his torrent file for an Anchor tracker, and obviously you can. I messed out some of the information. I hope it will not be identified later on, because obviously I have to pay him another invitation. So the thing is that there is a hash, basically stored in strings, before the actual announce part of the URL. And this hash identifies you personally and links you to your account inside of the tracker.
Yes. So the point is that in private trackers, if you are sharing your torrent files you have downloaded with your own ID, it means every time somebody using that particular torrent file, it means for the tracker it is used by yourself. So don't share it, of course. So what we see here, even if it's free or a private one, the tracker knows who are you. The private one knows better because they are having a closed environment.
Yes.
So what we see, the interesting part is that when you are doing the actual communication, there is a counting about the uploads and the downloads. So what the closed trackers are continuously fighting with to try to close out those clients which are trying to trick out these counts, the uploaded bytes and the downloaded bytes. However, everything is happening on your own client. So let's say you are not free, but you can do anything on your own computer. Please.
This basically, sorry, just a small addition. The whole communication goes normally over HTTP, and inside of this GET request, your client actually sends out the amounts of bytes it has downloaded for that specific torrent and the amounts of bytes it has uploaded to the specific torrent. So basically, nasty stuff. If you are modifying these counters, then you will be immediately banned from Anchor if they recognize this. So another version of this whole BitTorrent file sharing is over DHT, which means the distributed hash tables. So there are two well, not structures, but how do you call it? Two names are basically in used in DHT communication. One is a node and one is a peer. Your client over in DHT can be actually a peer if it's downloading one certain torrent, and if I'm interested in this torrent, or can be a node because if it doesn't have the torrent that actual peers for other peers for the specific info hash I'm looking for, it will give me other node information. That's basically an IP address and a port where I can connect and ask for my info hash. Yeah. So how does this DHT communication looks like? First, we have got a peer who wants to download data for a specific info hash. This peer goes to a node, connects it to the specified IP and port, and tells this computer, the service, that, hey, please, I have got this info hash. Do you have peers for this info hash? So the node can reply that, sorry, I do not have this type of info hash, but here are 8 other nodes where you can ask from. The peer then communicates with these other nodes if they have the specific info hash, and recursively it will go on and on and on, and it will eventually start an avalanche of communications, and which takes up a lot of bandwidth up until the point where it receives the actual. Can you put it back? So where it can acquire a specific amounts of peers, but this crawling can go over and over and over, since the actual amount of nodes and peers are constantly changing. There will be always a new node, so this search can go on forever. So just to see you how an actual of this communication looked like, we put together a small Python script that was logging all of the nodes and peers for an actual torrent, an actual Hungarian torrent. So we will show this animation. In this animation, you will see which was the torrent file for?
Oh, we had to choose a very popular one. Actually, this is the Jóban Rosszban, 2013, May 16th. And this is an AVI file, yes. So after the lot of theoretic stuff.
So in this animation, when we are playing it, yes?
So this is it?
These are the actual nodes and peers for the 10th, up till the 10th second of the communication when my client was searching for peers. And at the first, you will see this kind of a transformation, because the whole software that we used, it was called Gephi, if somebody used it before, which is really cool for not just for animation, but for visualizing graphs.
Yep.
So right now, we put together a directed graph for the nodes and the peers for this specific torrent. Basically, what we did, first we asked from let's say, the official BitTorrent.org DHT tracker if he knows nodes or peers, if he knows peers for this specific torrent, and then we went on and on and on and logged all of the IP addresses and the directions that which IP addresses came from which nodes as a response for our search. And afterwards, for the 10 seconds of communication, it looks something like this, and we basically built it a bit. We basically visualized it as a weighted graph. So the orange dots are having more and more and more, having lots of connections, and eventually, if we found a node which has got lots of connections, then it will become red, and then slowly the whole thing will transform to what was the exact name in English? Sorry, for the peer-to-peer.
Now we are seeing the so-called freescale network graph about the different dots we have connected with each other. What we did, we removed the labels because, of course, at least we can put their reverse DNS names. So all the different dots can have their own IPs. They have to have their own IPs based on the ref DNS. It will turn out that which points are connected to a single PC or one big company's outgoing point to the internet. Now we see that we just transform it in a way to see the dots. They are really a big number, and it is interesting because we only put here 10 seconds of communications. So this is the log of 10 seconds.
So first I told my colleague to try around with 1 minute, but the actual animation process was taking more than 4 hours and unable to fit on a small screen. So we just stick with 10 minutes at the end. So, but really, if you are crawling, there are multiple dots, multiple bots that are crawling over the DHT network just for educational purposes, of course. searching for an info hash, that's really unlikely to happen because of info hash is an SHA-1 hash. For example, if you are putting 20 bytes of Fs to search for an info hash, it will mathematically impossible for that specific hash to receive peers for. Anyways, there are some really, really strange findings that there are nodes who are actually giving you back information, peer information regarding this info hash. Those nodes are certainly malicious people or malicious servers who are trying to let's say, slow down the whole searching process for this DHT networks. Okay. Yeah, we can continue.
So,
yep.
Just like in the movie.
Okay, yeah.
Now you see me.
One extra information about DHT is that if you are joining the DHT network, your client automatically generates you a random number, 20-byte random number, which can identify your client over the DHT network, which is kind of a good stuff, actually. You can really quickly search for these node IDs and track the IPs and if you are looking up these IPs, for example, in a GeoIP database, then you can actually track the geographical location or movement of the specific, for example, laptop or smartphone or any type of embedded devices which you can carry with yourself. So, what else? Why is this whole ID came to life? Actually, is that first of all, for what have I written here? Okay. Well, basically, I already talked about the searching made easier. So if you are knowing, let's say, a specific node ID, that will most likely give you back peers for most of your info hashes. Then you don't have to search and crawl over the DHT network for that specific info hash, but you can easily locate this person or this computer with this ID. And start to acquire lots of info hashes from this person. And we have seen that people are trying to use this node ID as some kind of DNS server. So basically, people started creating trackers, and they didn't want to register a domain name for this, for example. And they created this tracker in a way that it will have its own node ID. And in the tracker field of the torrent file, they put the node ID.dht. That's let's say the universal location identifier of this tracker. The client, your BitTorrent client, automatically will search the DHT network for this node ID. And will initiate, after it received the IP and the port, it will initiate normal tracker communication afterwards. So it's like it's a tracker over the DHT network. Problem with this, that as all of the PHP protocols are proven to be non-secure, let's say, only in some really, really rare cases you can specify some kind of PHP peer-to-peer protocol, to be somewhat, let's say, reliable or secure. You can actually easily write the software that only thing it will do is to distribute multiple node IDs on the DHT network. And tell them that, hey, if you are searching for this node ID, then it will be me, and you should be connecting to me. And you can easily hijack all of the other people's node ID, and direct the traffic to yourself or to somebody else, because there is no proof and no security checks regarding this.
So in a short form, because we are talking about P2P networks, because every single piece on the network is also giving data and asking, requiring for data, it is possible for any of these points to give you disinformation. So in technical terms, we can say we can create attacks based on the routing. Okay, so we give disinformed routing information to any other peers based on the actual info hash. So it is possible that randomly or on a selected way, we are saying we are owning this and this and this info hash, please come to me, or use these and these and these peers, they are having this. What's the end result? The whole network will be slowed down, and it will stop for all that particular info hashes which are having fake information.
Yes, but what my colleague said, it's only in theory. In reality, lots of people actually and lots of companies have actually tried to slow down or stop the DHT network, but so far all of them didn't succeed or haven't succeeded.
Yeah, let's move forward.
So as a summary, we can say that when you are downloading some file with the use of BitTorrent, you are leaving traces of information about yourself or your IP and your port, basically the client service. What information you are giving out is basically you are giving out your IP and port, of course. You are giving out your node ID. It's really easy to do a reverse DNS on your IP and have your domain name, for example, if you are over a server and not using your ASDL or whatever internet connection. And also the tracker will eventually give out your IP address and your port number to other peers who are requesting information from the tracker to download your torrent. So yeah, we wouldn't call it in a really secure way. At least it's certainly not anonymous.
Yeah, if we are think about the other side, if we are downloading the torrents through the DHT network, we don't even need a tracker for that. But lots of different endpoints, lots of other peers or nodes will know your IP address and actual port you are sharing the actual info hash. And the real thing is that you don't have control over it. So what we did, actually, we didn't download the content, but we just made a track and we logged who is downloading what. And based on, we have built a huge database and made some statistical output about that. And also, having this kind of database, we have just raised the level of information we can put together from the pieces.
Exactly. I think we can move on to the next slide.
So what else the different BitTorrent networks, the actual existing networks, can be used for? We have downloading 16,000 of torrents from different places. We will show some charts about it, where the torrents coming from. With these torrents, we have reached 160,000 peers.
No, it's not.
140,000 peers, sorry. And just to be on the white side, we have just connected to public databases these information, of course. So reverse DNS and GeoIP connection has been made. So that particular animation you have seen, it is possible to see with the correct IP addresses and the GeoIPs. And also, there are certain additional values added, so we can track if somebody is moving from one IP range, one IP address to another one, and they are continuing downloading the same stuff, or they are continuing sharing the same stuff. So this is another way to track the people, even if they were not aware about this. So after the prison, I think it is something everybody should know.
Exactly. And one additional information, one of the We will show you charts later on, but this piece of information will not be shown on the charts. Just by looking up reverse DNS names and connecting them with node IDs inside of the database. If you are only connecting, if you are searching for similar node IDs with different domain names, you can actually come up with really, really interesting results. For example, we came, we found out that lots of people are turning their torrent clients on before actually connecting to the VPN that would hide them from downloading the torrent files. And basically, based on the node ID will be inside of the DHT network, and the DHT network will not forget the node ID and the IP of the originally connected client, because it has got some kind of memory, let's say. Eventually, when you are joining the VPN, the same node ID will show up, but with a different IP. And thus the reverse DNS will not be the same, but the node ID will be the same. So you can easily be, let's say, tracked over VPN if you don't know how to use VPN normally or correctly.
So the practical advice that the VPN client is always starting later than your torrent if it's auto starting. So please take out the torrent client from the auto start. So what else happening with the file sharing scene? Just to talk about generic ideas, which could be theoretic one, or maybe somewhere it's already happening. So if you are downloading something, it is possible that somebody, let's say governmental level, tracking what is happening on the actual P2P network, how it's happening, for example, in Germany. Particular lawyer companies are having technical people running torrent clients, and they are checking special torrent titles, for example, the newest blockbuster movies, or German German music. Sorry. No. Of course not. So
we have totally not checked them. So.
Like German-sourced movies and music. And if anybody appears on this particular P2P actual network, those IPs logged, and the owners of those IPs will have an official letter less than a month to pay X hundred.
No, it was like one not personal, but one close personal experience that a guy downloaded in Germany. Downloaded a movie that was recorded by a small camera inside of the theater, and he had to pay.
It was a cam release.
Yeah, cam release.
Sorry.
Thank you. So actually, he had to pay 2,500 euros for this specific download, and I think for a cam release, it just doesn't really worth it.
So even all your friend with a movie ticket would be cheaper. So the other scenario, that was the reaction-based, let's say, tracking. The other scenarios, when it is happening as a proactive one, how is it happening? Somebody is creating a fake torrent and checking who is jump on it. It could be the same area, it could be movies and musics and others, but also, let's not forget, the world has another half at least. So what if we are talking about highly violent topics, which are videos, but videos about how to put together nasty stuff, which is possible to change someone else's life in a very dramatic way.
Yes.
So the simple thing is that the particular government agencies creating these torrents and just waiting and waiting who will start to download it. And as you've seen the animation, it is really easy to not just have the IPs itself, who is downloading it, but how it's spread through, where it is coming from, who is the second one, who the third one, and at the end we have 178 different people downloading the same stuff. So please watch yourself. Here are some additional graphs charts, sorry. This is about what the ISP is having the different kind of network load. The network load is about the torrent downloading. So it is all the Hungarian ISPs which had more than 100 hits.
Yes.
Yes, 100 peers in that particular time when we made this tracking. Moving to the next chart. Here are the sources
that we used.
So this is the base. Yep. These are the different torrent trackers we have seen. And as we mentioned, this was purely a, how did you say?
What? Purely just...
It was about to check how is it happening, so not downloading.
Yeah, but
and either, yes?
Actually, guys from Anchor didn't really like the idea that we are doing this type of checks. So
yes, it was a very short time.
Yeah, so it's like I got banned from Anchor pretty quick. It was like 2 days or 3 days, but no problem. I'm a really agile and aggressive person, so there are some ways that can get this type of information.
Let me guess, there will be 2 guys never have access to
No,
Anchor
so
anymore.
the first, yeah, basically the first thing, again, why would somebody, knowing this type of information, why would somebody post its own Anchor downloaded torrent file on the internet, which contains the passkey, which I showed you before? By using the passkey, anybody can impersonate this guy and make downloads in the name of this guy from Anchor if he has got the info hash. So it's like, it just doesn't really add up.
Yes. So the last thing, this breakdown is just a simple search on the reverse DNS records we have been gathered. As you can see, there's a pretty big piece for the mail, which means we have just simply made a search if the reverse DNS record contains the mail. Why it is interesting? Because these are all mail servers. So I don't know if you have own a mail server and it is constantly downloading some torrent stuff. So I believe it's not part of the SMTP protocol, isn't it?
No, not really.
Okay.
Not really. As far as I know. But the most interesting, so these domain names we just did random searches for, and doesn't really show the exact amounts of hits. It's just for an eye opening. But for example, if you are seeing the last domain is like Indian government, which are having like multiple, but really at least 100 servers can be counted inside our databases. That the reverse DNS was ending with .gov.in, which brings up questions about let's say the policies they are enforcing within the government. Yes.
So basically, we are close to the end.
Yes.
What I like to have as a summary, so there are different kind of, let's say, different point of views we can see this. One is the actual end user, everybody. So please, protect yourself.
Yeah.
Don't think it's anonymous, because it's not. If you are using it, at least choose what you are downloading. If this is somebody on the employer side or on the business side, it would be a huge surprise for everybody to know how their, let's say, company-based resources being used continuously. So this solution that we have put together can help to identify it. And also on the government sector, I believe so, there are people who would like to see, if they are not checking already, what kind of named or anonymous activities are happening on the P2A networks.
Exactly.
So, thank you very much. Please, we are here to have some questions.
If anybody has some questions.
Yes, of course, later on. Please.
this is only the traffic is being encrypted between the different clients, but your actually IP address will still be stored. If it's a DHT, then it will store in all of the other clients that you are downloading torrent from. If it's a tracker, still, no matter the communication is encrypted, the data will be shared to all of the downloaders or the peers.
Yeah. In other words, you are part of the network. Everybody who is not part of the network, I'm in the P2P network, they are not able to see what's happening inside. They just see the ports are having a big number of traffic. But everybody who is in, they are seeing all the others.
Yeah.
Anybody else, please?
No?
Okay, so thank you very much for your time.
Wait. There's a gent.
Please. Sorry, can you please repeat? I just missed the beginning.
Let me just move it here. So.
Yeah. Yeah, that's the better.
I think the tracking port, sorry.
We have 1 minute left.
Oh, please, here. To my necktie. Yeah?
The question is that if the tracker is a private tracker, then the other guys who want to watch the traffic and observe the network itself, they have to be connected to this private tracker, so they have to be somehow part of this community.
Yes.
Yeah. And that was the long answer, yeah. But actually, how can anybody nowadays be part of a private tracker community? Most of the time, it is something happening by invitation. So I think this is the longer answer.
So it's kind of an easy to get part of the of a private tracker, because still you are trying to download a file. If you don't have enough people who are sharing the file, then the whole concept will just break.
Yeah. So we are out of time. Thank you very much. We are here for the whole day. So if anybody has any more questions, please find us.
Okay.
Not on the DHT. Thank you very much.
Thank you.